Hi, this lab is Lab 3 from Physics 2212. The purpose of this lab was to calculate the magnetic field due to the magnet at certain distances from the magnet. Fundamental ideas here are the equation of a magnetic field off axis, which is B equals mu naught over 4 pi times 1 over r cubed times 3 times mu dot r hat times r hat minus mu, and the equation of a magnetic field on axis. B equals mu naught over 4 pi times 2 times mu over r cubed. The measurements used for this lab were R20 being 0.317 meters, R70 being 0.213 meters, R120 being 0.179 meters, R170 being 0.161 meters, R220 being 0.148 meters, and D-perp being 0.285 meters. The results from this experiment were that the B field at R20 was 2.08 times 10 to the negative 5 teslas. Magnetic field at R70 was 7.03 times 10 to the negative 5 teslas. The magnetic field at R equals 120 is 1.20 times 10 to the negative 4 teslas. The magnetic field at 170 was 1.70 times 10 to the negative 4 teslas. The magnetic field at 220 was 2.21 times 10 to the negative 4 teslas. And magnetic field at the perpendicular location was 7.151 times 10 to the negative 5 teslas. K in this lab was found to be 5.767 times 10 to the negative 7, and mu was found to be 3.44574. The assumptions here was that the phone magnetometer was lined up with north exactly, which would cancel out Earth's magnetic field in the x direction. The system here is the magnet and the phone. The surroundings is everything else. The observation noticed for this lab is that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. As the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. For this lab, the experiment was to measure the magnetic field on axis to the magnet at different distances from the magnet. The distance and value of the magnetic field on axis were then recorded on the provided Excel sheet shown in the picture to the right. These recorded values were then used to make a plot, shown to the right, to find what k is. The natural log of k was equal to negative 14.366, as it is the y-intercept. This value helped to find the value of mu, as mu equals k times 4 pi over 2 times mu naught, which equaled 3.44574. The value of n was found to be negative 3.1113, as it is the slope on the graph. The next part of the experiment was to do a measurement off axis from the magnet. This measurement would be compared to the value given by the coding portion. For the coding portion, we were required to create a function for the B field and to model the magnetic field around the magnet. With the computed model, I got the magnitude of the magnetic field for the off-axis location to be 8.32095 times 10 to the negative 6 teslas, compared to the measured value, which was equal to 7.51 times 10 to the negative 5 teslas. I found I was off by around a factor of 10. Sources of error. The largest sources of error was misalignment of the phone with the cardinal north. If this is done incorrectly, the x component of the magnetic field would not be 0. Another source of error was magnetic fields that could interfere with the experiment. This is a possibility as I did the experiment in my dorm room. What if questions? What if you hadn't oriented the experiment to compensate for magnetic north and it instead laid out the meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? In this case, the measured x component would not be purely from the magnet, but a combination of the magnetic field due to the magnet and Earth's magnetic field. Depending on if the orientation was more towards east or west, the red value would either be smaller or greater, respectively. What if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? The magnetic field would be twice as large from the same distances. This is because taking two magnets together multiplies the magnetic field by 2, as one magnetic field plus another magnetic field that are identical equals the magnetic field multiplied by 2.